Hello, I want to continue functions. I think this particular video will end the direct information on functions. So far, we've figured out how to use functions, both void type functions that don't return values and functions that return values. We've also figured out how to do call by reference and call by name. Value, pardon me. Now, I want to play around a little. A function can return one value, and one value only. We'll find it can be very complicated. As we start looking at classes in a few weeks, we can return an object that has a lot of parts to it, but we can only return one thing. So, what if I want a function to do more than that? Here's the problem I would like to solve. Input the radius of a circle and compute the area and circumference and write a program, write a function to compute area and circumference and send these back to the caller. I could do these with two functions, one to do the circumference and one to do the radius, but I'd rather do one. So what do I do? Well, we know what to do, really. Last time we figured out how to do call by reference. That's what we're going to do. So I'm going to go to Visual Studio. I'm going to start a new project. And I'll call it area circum. Let's see it. Okay, here it goes. So, just in case, I think I want this. Especially since, to make any sense out of this, I'm not going to use integers. I prefer to use double in this case. So all I'm going to do is I'm going to have double radius and area and circumference. I think that'll be enough to remind me of what I want. Now I'd like to call, I do my usual, ask the user to input radius of a circle. I don't need the indel. What's the matter with me? I just need that. The reason I'm getting that error is because it's namespace and not namespaces. Cin radius. Now, what do I want to do? I want to have a function that sends me back two things. But it can't do that with a return statement. However, I can modify variables that are sent in. So why don't I have compute area circum double radius wait a minute, I can't put that there. What's the matter with me? I'm giving you the header. I'm going to pass the radius into it, and I'm going to pass the area and the circumference. And then when I come back, I'm going to see out for a circle of radius. Let's see, let's make it, let's have all the values be fixed. Let's set the precision at 2. Now that means that I'm going to get things like dollars and cents if they were money. They're not, but just if they were. Then I'm going to print out, I think I'll just print out the radius. I won't bother putting a set W. Area is, and I'll put out area, and circumference is, and I'll put out circum and the indel, and then my return 0. Now, as I tend to do with a lot of these functions, I've done just about nothing. I left all the work to the program. So the program's going to be called comp area circumference. So I'm going to put the prototype in first, and it's not going to return a value, so I'm going to call it void. This is going to be double, but here's the trick. This is a double, but it will be modified after I return. Some people call that an output variable. Some people would say radius is an in variable and area is an out variable as far as this function is concerned. As far as I know, that terminology is not standard for the C language, C++, but I have seen it applied to some places. So I'm going to take this now and write my program. So I'm now ready to write the program. So let's see. The area of a circle is pi r squared. What's pi? Well, pi is 3.14. That's an estimate. 3.1415, I think, is a slightly better estimate. But let's try area equals 3.1415 times the radius squared. Pi r squared. The circumference is 2 pi r, as I remember. So it's 2 times 3.1415 times the radius. No return. I'm just sending it back. Now, if you want to make sure of those formulas, if you're a little worried about them, you would go here and say something like formulas for area and circumference of figures. And it would tell you right here what is the formula for circumference? So let's see what it says. For a circle, radius is the distance, area is pi r squared, circumference is 2 pi r. So we got it right. Now, the next thing I want to say is, I'm going to run it. It's going to be okay, maybe, if I haven't made any typos. So let's see what happens. So let's try a simple one that we can figure out ourselves. I'll put in 2. Pi r squared should be 4 times about 3.1, so 12 point something or so. And 2 pi, 2 would be 4 times 3 point something. They come out pretty close. Pi r squared and 2 pi r came out a little bit too close, but we'll see. I think they're right. Pi r squared is right. Yeah, the other one is pi times r plus r. And I think that is correct. Let's try a different one. Let's try 3. We get 28, and we get 18, so we do get a difference. Now, those are estimates of pi. Some people don't like using estimates of pi. They prefer to use something closer. So does C++ have a close approximation to pi? The easiest way to find out is to say, I'm going to search for, let me close this and go here and say pi in C++. And it says pi constant in C++. Now we have to include C math, and it also says we should define use math defines. Well, that's one way. I'm not sure it's the only way. I'm going to try a little something else just to see if I might get it to work. I'm going to see about the math # include math in C++. Now, if you look here, C++ math has only includes C math, and pi here, they don't list it. I thought they had it there. I'll try again. I'm pretty sure pi's in there. I just have to is pi in C math? And it says the pi constant is m pi. It appears we still need the use math defines. So let's try it. Let's first put the include of C math in. C math. And now let's try and see what happens if we put m_pi. So down here, instead of 3.1415, we'll put m_pi, and down here we'll put m_pi. Now, the reason I showed you how to get this is in case you have troubles finding it someday or can't remember it. You use Google to figure it out, get it. The machine doesn't like that. It's complaining. The reason is it doesn't have that defined, I think. But we'll know in a minute. I'm going to try running it and see what happens. Errors. Undeclared identifier. That's because if you look at what we heard here, we have to have this line, # define, and then that exact line there. In fact, I'm going to copy this, and I'm going to bring it over here. And it should go before you use it, I believe. And there we are. And I believe it gets a semicolon after it, if I remember correctly. But I can always check. No, it doesn't. So we don't need it. Now, let's see. Did I do it right? It looks like I may have, so let's see what happens now. So now if I put in 3, I get the answers. They're more or less the same, but they're slightly different. The moral of this is that you can get most of the items you need if you're doing anything that requires formulas from CMath. But if they're constants, you have to put use math defines. Now, CMath, I believe, also covers sine, cosine, all kinds of things like that. If you go back here and you ask the question, what is in CMath? That's Python. This is C++ CMath. And it gives you a huge list of things that are in there. So if you wanted to find out what was there, you could do it. So there's that program. It's not a hard program. The purpose of it is to show you that you can return answers or send back answers in the arguments that go into the function. So we can use the arguments to send back the values we want from the function. And the program is right here. That's another good way to work with functions. Works fine for us. I can make this easier to see by getting it smaller. We may actually have it in. I still don't have one line, one page. I probably can't get one page, so we'll just leave it where it is. Well, I can if I make this a little smaller. Let's try 14. That'll fit better. Not perfect, but it'll fit better. Well, that's good. Now we have another approach. I'm going to give you a project very shortly involving the computation of the addition, subtraction, division, and multiplication of something called the complex numbers. Now, the complex numbers are a relatively simple concept. Actually, C++ has a set of complex numbers, but we're not going to use them right now. We're just going to work with them our own way. So to make sure that you see what's going on, I'm going over here, and I'm going to put complex number arithmetic. And you'll see what you get here. It shows you all the formulas. Oh, pardon me. These aren't the formulas. These are the answers to problems. I'd rather go backwards and get to something where I get the formulas. So let me get out of that. And here we are. So it shows you how to add. It shows you how to subtract. Multiply is more complicated. Division is even more complicated. In fact, they don't even bother putting it in. Well, I'll get that. And there's something called the absolute value, or the of a complex number. It's like the absolute value of a complex number. It shows you a little bit of a way of looking at this. Shows you these, gives you examples. I'll put out the formulas for you. What I'm going to want you to do is create a program that does lots of functions to compute these various arithmetic operations. So that'll be going out soon. I believe this is the end of my 3 items on functions. If you read the end of part 2, you'll read that I was picking up some cats tonight. They're here, but they're hiding. They haven't come out yet. So I'm hoping that they start getting unafraid soon. So see you later. Bye now.